Hi, let's graph some trig functions using amplitude and period. For each function, state the amplitude and period and draw its graph in the domain from 0 to 2 pi. Here we're asked to graph two functions, y equals 4 cos 3x and y equals 5 tan 2x. In order to graph y equals 4 cos 3x, we need to know what y equals cos x looks like. Here you can see the cos graph being drawn, starting at 1 and finishing at 1 at when x equals 2 pi. Halfway between those two x values, we have pi, and that will give us our minimum value of pi minus 1. Because we have an amplitude of 1, our graph will bounce between 1 as a maximum and minus 1 as a minimum. Halfway between these two x values of 0 and pi, we have the place where it cuts the x-axis first, at pi on 2, 0. You'll also notice that it cuts the x-axis again at 3 pi on 2, 0. That is halfway between pi and 2 pi. Now this general shape really important in order to draw y equals 4 cos 3x. So let's see how the change in the function affects the change in the graph. We have to compare this function with y equals a cos bx in order to get values for a and b. A is our amplitude, and our amplitude in this case is 4. B will help us work out our period by taking 2 pi, our current domain, and dividing it by the coefficient of x. This means that our period is 2 pi on 3, and our graph will repeat itself every 2 pi on 3 times. To work out how many times it will repeat itself within our wanted domain, we start with 2 pi and divide it by our period. This gives us a value of 3 periods within 0 to 2 pi. So let's see how that is affected on our graph. I'm going to start by changing our amplitude from 1 to 4, and you'll see how we go up to a maximum of 4 and a minimum of minus 4, but still maintaining that general shape. Next, what I'm going to do is I'm going to change my coefficient of x, or my value for b. This will squash it together so that my graph maintains its maximum and minimum of 4 and minus 4, but is now between 0 and my period of 2 pi on 3. This gives me 5 values, 5 important points: a starting point and an end point. Halfway between those two x values, I will get my minimum of minus 4, which is down here. And halfway between these two x values, I get where it cuts my x-axis at pi on 6, 0, and where it cuts my x-axis the second time at pi on 2, 0, halfway between pi on 3 and 2 pi on 3. Now let's take a look and see that being drawn. Notice how it goes through all 5 of those points. Now what I want to do is I want to replicate that. This graph is going to be repeated in this period here between 2 pi on 3 and 4 pi on 3. I have 5 important points: my start point, which is where I ended at, can't quite get on it, and my finishing point, which is going to be 4 pi on 3, 4. Halfway between those two x values, I'm going to get my minimum, which is going to be down at minus 4, and halfway between my middle x value and my starting x value, I'll get where it cuts the x-axis. And I'll also get to see where it cuts this x-axis for the second time once I see it drawn. So let's take a look. Cuts through the x-axis once and back up through the x-axis twice. Now you'll see here that it cuts the x-axis halfway between 2 pi on 3 and pi, which is 5 pi on 6. It also cuts the x-axis a second time at 7 pi on 6, 0. Why don't you try and pause the video now and work out where the start and end point will be, where the minimum point will be, and where the 2 points where it cuts our x-axis will be. Okay, let's see if this is what the points that you got. Our graph is going to go down to minus 4 and back up to 4 and finish when x equals 2 pi. You'll notice that it cuts through the x-axis here at 3 pi on 2, 0, and cuts through the x-axis here at 11 pi on 6, 0. So we have finished drawing our graph in the domain from 0 to 2 pi, having an amplitude of 4, so a maximum and minimum of 4 and minus 4, and we also have a period of 2 pi and 3, meaning that this graph will repeat itself every 2 pi on 3 times. Let's try and draw our next graph. This graph is y equals 5 tan 2x, and in order to draw y equals 5 tan 2x, I have to know what y equals tan x looks like. Y equals tan x has asymptotes at pi on 2 and 3 pi on 2. Between 0 and pi on 2, the graph starts with a y value of 0 and then tends towards infinity the closer it gets towards its asymptote. Between pi on 2 and 3 pi on 2, we start at negative infinity, we cross the x-axis at pi, and then tend towards infinity the closer we get towards our next asymptote. Finally, in our last period, we start at 3 pi on 2 in the negative infinity range, and then head towards 0 the closer we get towards x equals 2 pi. Notice how this graph cuts the x-axis in 3 points, at 0, pi, and 2 pi. We currently have a period of pi and an amplitude that is non-existent because it doesn't have a positive or negative upper or lower bound. Now let's have a look and see how y equals 5 tan 2x changes this graph. So we begin by comparing our graph with y equals a tan bx. This will give us values for a and b. Remember how amplitude was our a? Well, tan graphs don't have an amplitude, so we say that the amplitude is nil, as it doesn't have a maximum or minimum value. However, that a equals 5 will affect the shape of our graph later on. The b equaling 2 will change the shape of our graph. Currently, our period is pi, so by dividing it by b, we get the value of our new period, which is pi on 2. In order to work out how many periods we'll have, we need to start with our domain that we want, which is 2 pi, and divide it by pi on 2, the size of our period. Why don't you try pausing the video and doing this calculation to work out the number of periods? Okay, when you divide by pi on 2, did you multiply by 2 on pi, the reciprocal? The pi's will cancel out, giving us 2 times 2, or 4 periods within the domain of 0 to 2 pi. Let's see how this changes our graph. So the current graph is of y equals tan x. Let's see what happens when I change the coefficient of the x within the tan function from 1 to 2. You'll notice how this graph squashes together. It keeps its same general shape, but now it cuts the x-axis at 0, pi on 2, and pi. The asymptotes have changed as well. They're now at pi on 4 and 3 pi on 4. We now have a period of pi on 2, meaning that this graph will repeat itself every pi on 2 times. Let's take a look now and see what happens when I change the coefficient of the tan function from 1 to 5. See how the graph gets steeper? It just means that it's going to take a little bit longer to get towards infinity within the periods. What I'm going to do now is I'm going to change it back from a equals 5 to a equals 1 so that we can see what happens to the graph in the next period. What I'd like you to try and do is pause the video and try and work out where our asymptotes are going to be, where the graph is going to cut the x-axis, and what it's going to look like when we draw the graph. Okay, let's start off with the new asymptotes. We have asymptotes now at 5 pi on 4 and 7 pi on 4. When I change the value, when I show the next period, I'm going to start at pi, and as I get closer towards my asymptote, it is going to tend towards infinity. So as we get closer to 5 pi on 4, our graph is going to get towards positive infinity. After 5 pi on 4, we're going to start at negative infinity. We're going to cross the x-axis at 3 pi on 2, and then we're going to tend towards infinity again the closer we get towards our next asymptote at 7 pi on 4. After 7 pi on 4, we're going to start at negative infinity, and as we get towards the end of our domain, we're going to finish at 0. This is what the graph of y equals tan 2x looks like. I'm now going to change back the coefficient of tan so everything gets steeper, and this is what y equals 5 tan 2x looks like. Look, I hope this video has helped you in drawing tan graphs and cos graphs, and that it'll help you draw future graphs of trig functions. Good luck.